Hi friends, in previous topic we have discussed in detail Newton's second law and it's a correlation between force and acceleration. But there is one more situation, one more type of force is described that is called as impulsive force. It's a impulsive force. It's a 5.6 impulse. Many situations are there. We encounter examples where force acts for short duration of time and produce finite change in momentum of the body. For example, you all are playing ball hitting on the wall. Just if you throw the ball towards the wall, it bounces back from the wall. Now see that when the ball is in contact with the wall, this is wall and then ball comes here. Very short time, even the fraction of second, this ball remains in contact with the wall. Therefore, this time, delta T, we all know F is equal to dP by dt. F is equal to, it is dP, change in P divided by G. This delta T, change in time is very short. It becomes impossible to measure. When this becomes impossible to measure, then F delta T is possible to measure. The force which is exerted by wall on the wall is F, but we are unable to measure this time of contact. When this time of contact is very short, it's difficult to measure it, and therefore but then delta T we can measure in terms of F into delta T. In such a situation, we consider factor impulse is equal to product of force and time of contact, or it is the duration in which the change happens. And this is defined as impulse. Impulse is defined as the product of force and time during which the change happened. This is also equal to, it is delta T, which is change in momentum of the body. So this force I, product of force and the duration in which the change took place, is called as impulsive force. Traditionally, impulsive forces were taken different from the forces, but Newton considered them same as that of this force. So here change in momentum help to integrate impulse and force together. So this is the concept of impulsive force. Then unit of this impulse is Newton second or dyne second. So impulse is given by Newton second or dyne second. There is a problem based on this concept, that is, let us see the problem. It's a problem number 5.4, problem number 5.4, page number, it is 96. A batsman hits back a ball straight in the direction of the bowler without change in its initial speed of 12 meters per second. If the mass of the ball is 0.15 kg, determine impulse imparted to the ball. Assume linear motion of the ball. Its impulse is asked. The batsman in cricket, bowler is throwing the ball towards batsman. Batsman is playing and deflecting it back towards the bowler. Here situation is clear. Mass of the ball is given as, it is 1 point, or it's given as 0.50 kg. 150 grams. Its velocity is 12 meter per second. What is impulse? Impulse is equal to F into T. How to find out this impulse? Impulse by definition is equal to change in. Impulse is equal to change in momentum. I is equal to. So how much is a change in momentum? Let's see. That is bowler. It's a changing it to U. Now mass. So impulse is equal to m into v. Change in velocity, it's a deflected back, which is turned back towards this one. That is 0.15 into 12, which becomes 66 are there. 12 ones are, and then it is 8. See that it is the impulse when this one is when it is hitting the batsman. I. Now it hit the batsman and the direction of the ball is changed. There is a change in direction of the ball. That is again becoming I2 0.5 into 12, which becomes again 1/8. If this one we are taking as a positive, this one should be negative. So change delta P is equal to 0.18 minus 0.18, which becomes 0.36 Newton. So when delta P is 0.36 Newton, impulse will also be 0.36 Newton. We can take it in other ways. This example, impulse is nothing but change in momentum. Impulse is equal to change in momentum, which is m1 mv1 or v2 minus mv1. M is here, v2 minus v1. It is m is 0.15. It is 12 minus 12 because the direction of this velocity changed. That becomes 0.15 into 24, which one will become 0.36, or this multiplication 15 4s are 16, 36, 2 decimals, which is equal to 3.6 Newton. So change is coming as 3.6 Newton. This also somewhere this is not correct. This one is 1.8. Impulse will be equal to 3.6 Newton. But this is more easier to discuss it. This one goes little bit complicated. Don't follow this one. Please follow this method. Change in momentum you can. This one you can discard. Don't follow. That's all for impulse. Thank you, friends.